So let's start with the cosine squared of n. I'll move that over here. Okay, so the reason I said start with this one, but don't actually, start with it as an idea, but don't use it to solve, is because cosine is between -1 and 1. But if you squared cosine, it's between 0 and 1. Okay, so that's actually the one you want to start with. Because remember, once you square it, it's always going to be positive. Okay, so we're going to get those divide by 2 minus n. Okay, and before you do that, remember, as n approaches infinity, 2 minus n is actually negative for any value bigger than 2. Remember, once you plug in 3, 4, 5, it's always going to be negative. Okay, so once you divide each by a negative number, you have to switch your signs. Yes.
Can you explain how you got the 0 less than or equal to cosine squared?
Sure. Because all of your values always bounce between -1 and 1 for your cosine. But if you squared any of those values, they'll automatically become positive.
Okay.
So that means any of those values would automatically be between 0 and 1.
Okay.
Yes.
Isn't there a problem with dividing by 2 minus n in the sense that as n approaches infinity, at
Mhm.
some point it has to cross 2 and thus become discontinuous?
Oh, that's what I was like, as far as n is greater than 2. So as long as n is greater than 2, you're approaching infinity. Because remember, you're talking about really big numbers when you're approaching infinity. So 2 was left in the dust way back. So you're talking like billions and trillions and so forth and going and going and going.
Okay.
Yep, 2 is at the very beginning.
So it's saying that it's starting at 0 to go through it, so it doesn't really matter.
Yeah,
It
exactly.
should start far along the line before it even touches it.
Exactly. So it just, like I said, where it starts at doesn't even matter. You're looking more at the endpoints. Okay, so if we have 0 divided by 2 minus n, and remember you have to switch your sign. Cosine squared of n, divided by 2 minus n. Greater than or equal to 1 over 2 minus n. Which means we can go ahead and flip everything. 1 over 2 minus n is less than or equal to cosine squared of n divided by 2 minus n, which is less than or equal to 0 over 2 minus n is just 0. Okay, so now we get the limit of each one of those terms as n approaches infinity. Of each term. So if we get the limit of 1 over 2 minus n as n approaches infinity, which is less than or equal to the limit of cosine squared of n divided by n as n approaches infinity, which is less than or equal to the limit of 0 as n approaches infinity. Okay, so as n approaches infinity and gets bigger and bigger and bigger, you get a constant as it's getting closer and closer and closer to 0, but just from the negative side. So this is just getting closer and closer to 0 from the negative side, but it's still just going to be 0. Okay, which is less than or equal to the limit cosine squared of n divided by n, which the limit of 0 is just going to be 0. Okay. So we know that this is going to have a limit of 0. So cosine squared of n divided by n as n approaches infinity equals 0. So we know it converges. All right. Any questions? Yes.
I mean, the symbols don't really matter in the end which direction they're going, but
Not
in-
really. Technically, it's you're
but in
supposed
the
to follow it,
in
but
the second
Mhm.
step,
Mhm.
you swapped them because you were dividing by a negative number.
Yes.
But then you flipped the order. Didn't you undo what you did?
Not really, because it's kind of thinking like this. So let's say if you have here we flipped the signs. So if you have 3 is greater than or equal to 2, which is greater than or equal to 1, you can actually flip them all to make it 1 is less than or equal to 2 is less than or equal to 3. So here I had everything in order as far as from greater than to smallest,
Yeah.
but you can flip the entire thing over, which is what I did there.
But that's not really doing the inverse, right? It's just.
Oh no, it's not an inverse, it's just flipping the order.
Oh, okay.
So it's just like if we had 5 is greater than 4,
'Cause
it's the same as
typically-
4 is less than 5.
Yeah.
So we're just flipping it over.
Because if you were to divide by -1
Mm-hmm.
on both of those,
Mhm.
and you get -5, then you'd swap the sign, but you'd keep 5 on the left side and 4 on the right side. You just switch the sign.
Oh, you mean if you divide both of those by -1?
Yeah.
Yep, because you have -5 is less than -4.
Yeah.
Yep.
Because in the top one,
Mhm.
you had the 0 on the left side,
Mhm.
and the 1 on the right side,
Yes.
and then you divide it by a negative, but then you swapped them. Usually you keep it on the side that it was on.
You mean
Which is why I was just
for...
asking. Yeah, because the 0
this
was
one?
on, in that one,
Mm-hmm.
0 is on the left,
Mm-hmm.
and it says it's greater than the cosine.
Mm-hmm.
But then when you put it in the next one,
Mm-hmm.
0 is still greater than the cosine. So you didn't really change it at all, you just moved it.
Oh no, we just made it cosine less than 0. Yeah, that was all, just flipped it around.
Okay.
He changed it in the previous step. The step above it is when he switched the greater part, greater than less than signs.
Okay, so that one was just reordering it.
Yes, exactly.
Okay.
Does that make sense?
Yeah.
All right. All right. Any other questions? All right. Oh, make sure anyone's done writing. Okay. So let's try this one. Oh, move that out the way. All right. Now with this one, first thing I do is rewrite it. So if you have 3 and times tangent inverse of n minus n divided by n, make that a little bit longer, that just equals to 3 times tangent inverse of n divided by n minus 1. Or you can just make it 3 times tangent inverse of n divided by n minus 3. Oh, might as well put that there. Okay. And once again, we're starting to where we know the boundaries are for your tangent inverse. Okay, so negative pi over 2 tangent inverse of n is less than pi over 2. Okay, we can just multiply each one of those by 3. Oh, Actually, let me kind of separate those so they're not confused. Okay, so we have negative 3 pi over 2, which is less than or equal to 3 times the tangent inverse of n, which is less than or equal to positive 3 pi over 2. Okay. Then we just subtract 3 from each term. Okay, so negative 3 pi over 2 minus 3 is less than or equal to 3 times tangent inverse. Oh, did I forget to divide by n? Yep, forgot to divide by n. Okay, divide by n, then subtract 3. Uh-oh. There we go. Okay, so that would be 3 pi divided by 2n is less than or equal to 3 times tangent inverse of n divided by n, which is less than or equal to 3 pi divided by 2n. Okay, now we subtract 3. Okay, so we have negative 3 pi divided by 2n minus 3, which is less than or equal to 3 tangent inverse of n divided by n minus 3, which is less than or equal to 3 pi over 2n minus 3. Okay, so we have our middle term matching exactly what we wanted. So now we get the limit of each one as n approaches infinity. So that means we have the limit of negative 3 pi over 2n minus 3 as n approaches infinity. It's less than or equal to the limit of 3 times tangent inverse of n divided by n as n approaches infinity, which is less than or equal to the limit of 3 pi divided by 2 times n. Oh, forgot my minus 3. As n approaches, oh, forgot my minus 3 here too. Minus 3. Move that over a little bit. No point in trying to cram it all in there. Minus 3. Limit as n approaches infinity of 3 pi over 2n minus 3. There we go. Okay. So once again, if we did decide to distribute our limit, we know we have a constant divided by n that's getting bigger and bigger and bigger. So you have 0 minus 3. So this limit would end up being negative 3, which is less than or equal to the limit of 3 times tangent inverse of n over n minus 3 as n approaches infinity, which is less than or equal to, once again, you have a constant over an n that's getting bigger and bigger and bigger. So you have a limit of 0 minus 3, which again is negative 3. Okay. So by the squeeze theorem, we can pretty much say that the limit of this, 3 tangent inverse of n divided by n minus 3 as n approaches infinity equals negative 3. So we know it converges. All right, any questions on this one?
Actually, about the last one we did,
Mhm.
the cosine squared, then
Yes.
11 What's the negative term divided by? Was that 2 minus n? Or
Yep, because whenever when n is greater than 2. So every n value after 2 would give you a negative number.
okay.
So whenever you divide by a negative number, that's why we had to switch the sign. Mhm. Okay. Any other questions on this one? All right, so we're going to cover one more thing. And that's monotonic and bounded sequences. Okay. Monotonic just means it's always increasing or always decreasing. So sequence is monotonic if the terms are non-decreasing which means that your A1 less than or equal to your A2 less than or equal to your A3 all the way up to some less than or equal to A sub n, which all the way up to infinity. Or non-increasing. Which means that your first term is greater than or equal to your second term, which is greater than or equal to your third term, which goes all the way to some nth term, which goes all the way to infinity. Okay, so if you had your A1, A2, A3, A4, A5, and it's going up higher and higher and higher, it's non-decreasing, which means it's monotonic. And even if you had one that's, say, is going down, it's decreasing and decreasing, let's say you've even turned to a constant for a second. But it's going back down. Okay. Now, it may not be constantly decreasing, but it's not increasing. So it's non-increasing, which means it's still monotonic. Okay. Now, if you had one that went up, and then eventually went back down and went back up again, it's not monotonic, because of course it's not non-decreasing and not oh, that didn't sound right. It's not, it's decreasing where it shouldn't be and increasing where it shouldn't be. That not non, oh man, that threw me off. Okay, so it's not monotonic. Okay, so another way to say it is like this. Let's say, in other words, non-decreasing means that your A sub n is less than or equal to the following term, and non-increasing this means that the previous term is bigger than your next term. Oop, I'll leave that up for a few seconds. Right, so let's say, for example, let's say if we wanted to determine if the following are monotonic. Okay, so let's say for problem A, we have b sub n equals 2 times n over 1 plus n. And let's say for problem B, let's say if we have our c sub n equals n squared over 2 to the n minus 1. So there's actually a couple of ways you could solve these. There's no one set way. Okay. So for A, let's say if we let b sub n equals 2 over n over 1 plus n, and b sub n plus 1 equal to 2 times n plus 1 over 1 plus n plus 1. Okay. So we just want to see if it's less than or equal to or greater than or equal to. Okay, so we know b sub n is going to be one or the other of b sub n plus 1. Okay, so that means we have 2 times n over 1 plus n is going to be something of 2 times n plus 1. Well, might as well make it 2n plus 2. Over n plus 2. Okay. So here we can actually cross multiply. So you have 2n times n plus 2. And we have 2n plus 2 times n plus 1, or 1 plus n, whichever way you want to write it. Okay, so the left side, we have 2n squared plus 2. And here, if you actually FOIL it out, uh-oh.
4n.
Hmm?
Wouldn't it be 4n? The 2n squared plus.
Yep. Yep, 2n squared.
I mean, on the left side.
Oh, yep, 4n, thank you. Don't know how I missed that one. Okay, so you have 2n squared plus 2n minus 2n plus 4n plus 3. Okay, so we know this is always going to be less than or equal to. Okay, now since b sub n is less than or equal to b sub n plus 1, b sub n is monotonic because it's non-decreasing.
How is there a plus 3?
Did I say plus 2? Don't know why I put 3 there. Oh my goodness. So it's monotonic, which means it's non-decreasing. Let me put the instruction here. cross multiply. All right, any questions on that one? All right, and on some of them, you can just plug in a few values and see where it's going. So for B, let's say if we make n equal 1, you actually end up with 1 over 2 to the 1 minus 1, which is 1 over 1. Let's say if we make n equal 2, n squared, so you end up with 4 over 3. Let's say n is equal to 3. You end up with 9 over 8 minus 1, which is 7. Okay, so here we know that our c sub 1 is less than or equal to c sub 2. But 1 1/3 is bigger than 1 2/7. So c sub 2 is greater than or equal to c sub 3. So just that fast, we prove that it's not monotonic. But the thing is, the higher this goes, this actually will remain true. C sub 3 will be bigger than C sub 4. C sub 4 will be bigger than C sub 5. So if we drop the first one, it would be monotonic. But as long as we have that first one, it's not monotonic. Make a little side note. Dropping the first term would make this monotonic. All right. Any questions on that one? All right. Okay. And bounded means just that. You're bounded above or below by a value. And it's a pretty quick explanation for that one. That'll take probably every bit of 2 minutes. Okay. So for example, let's say the sequence a sub n equals 1 over n is bounded below by 0. Okay. So really that's just its lower limit. So you have its lower limit, which is bounded below, or you can have an upper limit, which is bounded above. Okay. And also, it's monotonic, because as n gets bigger, it just keeps getting smaller and smaller and smaller. Uh-oh, now it is. Okay. So since it's bounded and monotonic, kind of stands to reason that it converges. Because if it never crosses that 0, it converges to 0. Since it is bounded and monotonic. Okay, so if we have one that's, let's say, c sub n equals -1 to the nth power. Now that's just going to bounce back and forth between -1 and 1. If n is